Okay. So we need to finish this guy because we're right in the middle of it, unfortunately. So the deal is this. Somebody owns this apartment complex and they want to increase their revenue. Revenue is determined by the number you sell times the amount, the price each. So they start out selling 800 of them for $300 each, but then they decide they're going to lower the price in increments of $5, which causes their sales to go up in increments of 20. So the question is, we want to maximize revenue. The word maximum means high point.
Yeah.
When you look at this equation, think about foiling it out. And I'm going to have to be really careful with my zeros here. Okay, so it looks like I get, if I did that right, negative 100x squared plus 2000x plus 240,000. Hopefully I got all the right zeros in the right spots. Let me know if I didn't, please. So we've got a quadratic equation whose coefficient is negative. So we know what that means. It's quadratic, so it's a parabola. It's got a negative coefficient, so it's upside down. So it looks like this. Isn't this the maximum? So we're going to find our vertex, and you can do that either by completing the square on this, or negative b over 2a. Which again, if my equation's right and my arithmetic's right here, I got 10. Now, what does that 10 stand for? 10 what? $10?
You're 10 times.
10 times. So I am going to lower my price 10 times. Which means I'm going to lower it $50. Which means I'm going to charge $250. Now I need to look at the question because there's lots of questions we can answer. What is the one I'm trying to answer?
The rent.
What rent will yield the maximum monthly income right there? Now, what if we wanted the income? What if we wanted to know, okay, what is my maximum income going to be? Then this is my income equation, or this, any of these are. I would plug 10 in there and figure that out. Now, I told you there were 2 ways to do this, and I actually lied, there's 3. Because we did it this way with the negative b over 2a. We could have completed the square, gone through these steps exactly, and that would have worked. But I want you to think about the equation that we started with. Everything here is fine. Everything is fine. But think about that equation that we started with. If I were to let x be negative 40, would you agree that my y value would be 0 if I put negative 40 in there for x?
Yeah.
And over here, if I put 60 in for y, would you agree that I would get 0? Or 60 for x, I would get 0 for y? So remember, the shape of this is a parabola. And we know that parabolas are symmetric. So doesn't it make sense, my picture's not very good, the 60 is supposed to be out here a little bit. Doesn't it make sense that, pretend that's parabola. Doesn't it make sense that the axis of symmetry will be right in the middle of those 2 zeros?
You just find the midpoint?
Zeros, so the midpoint of negative 40 and 60 is 20 divided by 2, which is 10. So that's another way. If you know your x-intercepts, which anytime you have factors, you have your x-intercepts. The x-intercepts come right from the factors, solving the factors. Anytime you have those, you can find your vertex just by doing the midpoint. Okay? All right. So enough of that for now. Hang on. Leave those notes out in case we have time to do more. But I said that I would answer any questions you thought of during lunch. So, did you think of any questions during lunch, Oliver?
I just had one more question about this. Could we use that idea for the boxes where we have to cut out an X for each
You gotta
one?
be careful because when we cut out an X, then we have a cubic. Remember? Length, width,
Yeah.
height. And cubics do not have that kind of symmetry. So, no.
Okay.
This is only gonna work with parabolas.
I just have a question on number 20. When you're asking, so you're asking for the maximum volume of the box, which, oh, sorry, number 20 on the review sheet. Yeah.
Uh-huh.
When you're asking for the maximum volume of the box, that's our y coordinate when we find.
Yes.
So then on the answer key, when I checked it, it said 2.43, but that's, so is it wrong?
Yes. It
Okay.
should be the,
I got like 240, I think.
I don't have the answers here, but yeah, I'll make a note that needs to be made.
What?
Alright, so all I did was find the X and I need the Y.
Yeah, the,
Yeah, so all you have to do is put that back in.
yeah,
Or
okay,
if
I
you're on
was,
your calculator, it'll just give you the Y.
yeah, I just didn't know if I was making
No,
it
you
wrong.
are right, so let's make sure, I made an error on that answer sheet apparently. So, make sure that you're answering the question that's asked. So, you're doing your box problem, you've got your, whatever, it's not a parabola, piece of a curve, a piece of a cubic curve, and you have found your maximum to be 2.43, comma, 219.87, I'm totally making that up. That's what you found your maximum to be. What does the 2.43 represent? This is a volume of a box problem. So this is your X, which is the size of the cutouts, right? And then this is your Y, which is your volume. So you want to make sure when you answer the question that you are answering the question. So if it says how big are the squares, then it's 2.43 inches or whatever. If it says what's the volume, it's 219 cubic inches or whatever the unit is. Okay, yes, sorry about that, Leah. All right.
This is very, a basic question that I just got confused on. Number 3, proving if it's odd or not.
Okay, did I do this yesterday? Okay, how do I prove if something is odd? What does odd mean?
Symmetric about the
It
origin.
has symmetry about the
Origin.
which means that changing the sign on X is going to change the sign on Y. So I could take my original equation put in a negative for both, clean it up a little bit. And if I get the same equation that I started with, then it is odd. Is it?
No.
No, because I did not get the same equation.
Okay, so I just messed up on like what I was doing, the whole thing. I thought that odd, the way to find out if something was odd or not, was to see if its inverse was the same.
No, because that's symmetry across the identity line. Doesn't have anything to do with the origin.
Gotcha.
All right, anybody else find something? Uh-huh, Sarah?
Can you draft 12B, please?
All right, so first, I gotta think about what's happening. So I got my original picture, which has a dot picture. So what's happening in this one?
Is being moved to the
When you move how?
it's being moved to the right.
Right two,
It's being flipped across the x-axis.
upside down or across the x-axis.
And the slope's being changed to 1
So it's half as tall. Right? It's half as tall, upside down, and move 2 units to the right. Now, I'm gonna do that in a couple of different steps. I'm not gonna try to tackle all that at once. So the first thing I'm gonna do is move it right 2. So I'm gonna pick up this picture and move every point over right 2. So the original, and I hope I counted right, I have the original at -5, -2. So that's now moving to -3, -2. This one is coming over here to 1. That one is coming here. This one, oops, is here. And this one now is gonna be over 4, 6. Okay, so moving it to the right, 2, I get that, I think. Okay? Now, I'm gonna turn it upside down and make it half as tall. Now, you might be able to do both of those things at once. That's just gonna take this y, which is at -2, is now gonna be half, so it's gonna be -1, but it's gonna be upside down, so it's gonna be at 1. So that point is just right there. Now, what about this one? His height right now is 0. He's not going anywhere. He's staying right there. This one is coming down, and he's only gonna be 1 now. This one is coming down, and it's going to be a half. And then this one is up 6, so he's going down 3 with that little curly thing. Does that make sense to you? All right. Anybody else? Huh?
Why do you put that curve on that?
It's the part of the original picture.
Just part of the original.
Yeah.
Keep it too big.
All right, gotta find the inverse and find the domain and range of each. Now, okay, you've done a couple of these, folks. What do I need to do to find the inverse? Yep, so this is now going to become x equals y plus 1 over 3y minus 4. Okay, then what? Okay, folks, we're not wasting time. We're using this productively or we're not going to do it. So 3xy minus 4x equals y plus 1, getting rid of the fraction. Now here's the key to the problem. This is a step you cannot not do. What do we have to do if we're trying to get y by itself?
Get the y's on the side.
Get the y's on the same side. Then we can factor them out. And then we can divide. And here's my inverse. Now, the domain of the original is everything except 4/3. Would you agree with that? So everything except 4/3 is the domain of the original. What about the domain of the inverse? Everything except 1/3. Now, if we've done this correctly, this domain right here should be the range of that guy. Where's the horizontal asymptote in this picture? What that means is when you draw the picture, it's not going to cross 1/3, which means the range is everything except 1/3. And down here, the range is gonna be everything except 4/3. Because if you indeed do have inverses, then the domain and range get flip-flopped just like the variables got flip-flopped. All right? Oliver?
Could you do 4?
What does this even mean? What am I going to be doing here in this problem?
Substitution.
Find the direct algebraic relationship between x and y means write an equation like this that is a relationship between x and y. Well, what's wrong with this? It has t's in it, right? These are parametric equations. We do not want t's, so we gotta get rid of the t's. Well, probably the easiest thing to do would be to substitute them out.
Which number is this?
It's 4.
4.
So, personally, I don't mind that equation. What is that? Is that, first of all, is that a direct algebraic relationship between x and y? Yep. What shape would that be? A sideways parabola. That's exactly right. It's a sideways parabola. Any idea where its vertex is?
4.
Why is the vertex at 1, 4? Because when you write an ordered pair, which letter comes first? X. And isn't your y the 4? Yep. So it'd be 1, 4. Yep. Write 1 of 4. All right, that takes care of that. All right, one more, and then we're going back to our notes. Tess? Huh? I can't hear you.
I'm confused how you found the vertex.
Okay, Tess, think now, where would the vertex of this be? If you were gonna draw this, where would the vertex be? Okay. So, the format of the equation is identical, so nothing's changed in terms of, you know, the math. What has changed is the order of the variables. X is 4, y is 1, right 4, up 1. But this is the y, so this means up 4 and right 1. Right? The variables behave just the same. They're just, the equations turn around. All right, so one more. One more? Before we have to do this tomorrow?
Can we do 7?
7. All right, how do we prove things are inverses? This was a homework question, and we did it in the homework. How do we prove things are inverses?
Plug them in for each other, like you do.
Plug them in for each other, said beautifully, yep. Plug them in for each other, and what has to happen?
They're supposed to be equal.
They have to come out to be X, or in other words, everything has to cancel out. So if you built the composition, f of g, that means you're plugging g into f. So you'll have 3, 7x plus 2 over 3, minus 2 over 7. So plug in this in right here. Now, that looks really bad, but it's not, because don't these cancel? So now we have 7x plus 2 minus 2, which is 7x, over 7, which is x. So that works. And then if you do it the other way, you're going to plug the f thing into here. You're going to have 7 3x minus 2 over 7 plus 2 over 3. Plugging this in here. So again, these are going to cancel, the 2's are going to cancel, the 3's are going to cancel, and we got it, right? Proving that they are inverses. Now, if you do that, and let's say, I don't know, let's say this stuff doesn't cancel, and you're not left with x, then you've just proven that they are not inverses. Yeah.
Can I also just take the inverse of the first one and then see it equals the second one?
Okay, that's not really a proof.
Yeah.
Okay, so yes, you know, you can do that and assume that you get the second one right, but here's what's happened. Somebody has already done that, Oliver, and you are checking their answer, basically. So your proof is going to be the definition of inverses. And the definition of inverses is this equals x and this equals x. That's how you prove. Okay. All right, that takes care of that. Tomorrow we have a test. Let's get our notes out. We're gonna do one more problem and then I'll shut up. But I want to do one more quick whining and complaining. Tomorrow's test is part calculator, part no calculator. Way more no than there is with. So be ready. All right, number 9. Jack was all this stuff. All right, so how does Jack calculate his total sales? Well, right now, he has 30 people, and they are averaging 50,000 each. So wouldn't his total sales be 30 times 50,000? Total sales for the company, 30 people making 50,000 or selling 50,000. But what's happening? He's going to hire some people. He's going to hire some people. So we're going to let X be the number of people hired. So what's happening to this 30? He has 30 salesmen right now. What's going to happen to that?
Plus X.
They're going up. What's happening to the sales per person?
Minus 1,000.
Minus 1,000. Does this look a lot like the apartment problem? If you FOILed all that out, which you can, if you did, would that give you a parabola opening down?
Yes.
Negative x squared, which would be a vertex problem then to maximize. We also talked about we could do this other ways. We could, well, can we figure out where the intercepts are here? Where is the 0 for this factor? Negative 30. Where is the 0 for this factor? Watch the zeros. Is it 50? All right, so here's my parabola again. Is our maximum at 10 again?
Yeah.
So what does that mean?
You need to plug it back in.
He should hire 10 people?
So 40.
And then he'd have a total of 40 salesmen. Is that okay with everybody?
And then to check that, because we kind of just like guess, well, not guess that it was 10, we would do the distance formula to actually like confirm that it's 10.
I mispointed, so I don't have to confirm it. I mispointed. Negative 30 plus 50 is 20 divided by 2 is 10. So I didn't guess, I did a midpoint. Yeah.
Could you also do like vertex, like
Yeah.
negative two?
Boil all that out, and then negative B over 2A. Yep, or complete the square on it, you got it all figured out. All right, that's it, tomorrow's test day. Can't wait.